My name is Vahid Naderyan. I'm a graduate student in the physics department. Did you know that wind shakes the ground? Today I'm going to tell you about my master's research on the coupling between the wind and the ground. As wind blows over the ground surface, it will push the ground and actually it will shake the ground. Unfortunately, or maybe fortunately, no one has ever studied in depth this natural phenomenon, and I'll tell you why. The physics and the mathematics which explain the wind theory are very complicated. So the geologists who study the ground, they do not necessarily know much about the wind theory. On the other hand, the scientists who are experts on the wind, they do not necessarily know much about the ground. So I was the lucky person to bridge this gap working with two research advisors, one who is a geologist and the other one who is an expert on the wind theory. The main reason that we study this basic and natural phenomenon is to understand, explore and explain this phenomenon. This is what physics does. But in addition to that, this natural coupling sometimes causes problems. There are sensors which measure the ground vibrations for many different applications, such as civil engineering, oil and gas industry, and earthquake studies. Imagine a large oil and gas company deploys hundreds of these geophones in a field to do a survey. If wind starts blowing, it will shake the ground and produces the noise on the geophones, on the sensors. So they have to stop and wait until the wind stops, and it could be days. And so this is going to cost a lot of time and money. So the ultimate goal of our project is to find a solution for this noise problem. As physicists, we always like to study and understand the physics of the problem as a first step. So we combined the wind theory and the ground theory, and after many manipulations, we figured out a huge complex mathematical formula which we claim predicts the displacements of the ground due to the wind. But we had to verify that. So we took our sensors out in the field on windy days and we directly measured the ground displacements due to the wind. And we got a great match between the results of the measurements and the results of our predictive mathematical model. Now we are in the last step of finding a solution for the wind noise problem, and this understanding is going to help us a lot.